Hello students, today we will be going to discuss chapter 5b of references Salinas concise chemistry, and will be on relative vapor density. This is the key equation. 1 mole is equal to molecular weight is equal to Avogadro number is equal to 22.4 liter or 22,400 cc only for the gas. Now first we will come to know what is relative vapor density. This is the ratio between the masses of equal volumes of gas or vapor and hydrogen under the same conditions of temperature and pressure. Therefore, relative vapor density is equal to the mass of volume V of the gas under similar conditions divided by the mass of volume V of the hydrogen gas under similar conditions. Here hydrogen gas is the reference, and don't mislead this similar condition with STP. This similar condition may or may not be STP. As per Avogadro's law, volumes of gases at STP may be substituted by the molecules. Therefore, relative vapor density can be given as mass of one molecule of the gas or vapor divided by mass of 2 atoms of hydrogen. Here I have directly written 2 atoms of hydrogen instead of molecule because one molecule of hydrogen contains 2 atoms. Now you multiply both the side by 2, you will be getting 2 into relative vapor density is equal to mass of one molecule of the gas or vapor divided by mass of one atom of hydrogen. If you remember from the previous video of mole concept, you will be finding this is the basis of the hydrogen scale of defining molecular mass. So, 2 into relative vapor density is equal to relative molecular mass of a gas or vapor. Therefore, relative molecular mass of a gas or vapor is twice its vapor density. Now, it was found that 1 decimeter cube or 1 liter of hydrogen at STP weighs 0.089 gram. Now, if vapor density of hydrogen at STP is D, then weight of 1 decimeter cube hydrogen is D into 0.089 gram. So, D into 0.089 gram of hydrogen occupies 1 dm cube at STP. Therefore, D gram of hydrogen occupies 11.2 dm cube at STP, or 2 d gram of any gas occupies 22.4 dm cube, and we know 2 into vapor density is equal to molecular mass. So we can say molecular mass is equal to molar volume, with the value of which is 22.4 decimeter cube, and this 22.4 decimeter cube is applicable for gas only. So the relation between these three terms, gram molecular mass of any gas occupies 22.4 liters at STP, which contains 6.022 into 10 to the power 23 molecules of that gas and is equal to 1 mole of that gas. Now, definition of molar volume. The molar volume of a gas is the volume occupied by 1 gram molecular mass, or simply by 1 mole of gas at STP, which is equal to 22.4 liters. Now go to example 10 of page 80. There we will find you have to find out how many atoms are present in one molecule of chlorine, that is the atomicity. What is given? Given is 35.5 gram of chlorine occupies 11200 cc. We know 35.5 gram of chlorine is equal to 1 gram atom of chlorine. Such type of relations should be remembered by you, and this will be remembered only by practicing different problems. We also know 1 mole of any gas occupies 22,400 cc at STP. So 112 cc volume is occupied by 1 gram atom of chlorine. This is given in the problem. So find out how many gram atoms of chlorine are present in 22400. You will be finding it is coming as 2. Now this is molar volume. So 2 gram atom will be your molecular weight. That means weight equivalent to 2 gram atom of chlorine will be your molecular weight. So 1 molecule of chlorine contains 2 atoms. In your book, that is in Salinas concise chemistry, this is done in a different manner. So you can do either of the way. Now go to example 13 of page 81. First, write the balanced equation separately for complete combustion of CH4 and H2. Means CH4 plus O2 gives you CO2 plus H2O. Here H2 plus O2 gives you H2. Then you find out how much methane reacts with how much oxygen. As per reaction, you will find 1 volume of methane reacts with 2 volume of oxygen to produce 1 volume of carbon dioxide and 2 volume of water. So third step is find out how much oxygen is required by the given methane, that is 224 cc. You will find it is 448 cc. Similarly, find out how much amount of CO2 and H2 is produced. This is the same way you are doing for problems related to Gay-Lussac's law, which you have covered in 5A. Now fourth step is follow the steps 1, 2, 3 for hydrogen combustion reaction equation. Now club up total oxygen required for CH4 combustion and H2 combustion. Total volume of CO2 produced, same way. And total steam produced. Now we have to now concentrate on the steam. Steam 560 cc you will get. We know 22,400 cc steam weighs 18 gram. 18 gram is the molecular weight of steam, that is water. So find out the weight of 560 cc of steam. Example 14, page 81. It's very easy one. First find out the vapor density of the gas. These all conditions are, all data are given. Then find out the molecular mass by this relation. Do the same for gas 5. Now exercise 5b, problem 19. Now problem 19 and problem 31 was told not to be done in the previous video. But now I am telling you to do this because you are already knowing this. These are simple statements. You just read these statements, you will be understanding. There are 2 extra problems I have given. First problem is related to the first example. These relations are given. You can find it out using these 2 relations and you will be finding the atomicity of the gas. Second problem is on the basis of a mixture where the basis is 100 gram. 66% of CO2 is present, so find out how much hydrogen is present. Then again these 2 relations, one relation is known to you, second relation molecular weight is equal to mass by number of moles. By using these 2 relations, solve this problem. Though the answers you will be finding little different, you might be having doubt, but these are the answers as per this problem. So complete the exercise 5B and wait for the next videos for 5C and 5D. Now this is the summary relation between molecular weight and vapor density, and this is the main relation which you have to remember. Thank you so much. Stay safe at home.